Yes, I'll pop in with another one about this idea of estimating population size from kinship. Maybe it's Mosh here, but anyone can answer it. What do you think would be the challenges of adapting these kind of census population size estimators that have been developed for mostly fisheries to insects?
Good question. I mean, one of the things that would leap out at me, and something that Mosh has obviously done a lot within our modelling, is, you know, really you want to think about what life stage you're sampling at. For instance, you want to think about you know, what spatial scale you're looking at over. Yeah, I mean, it's kind of designing how to actually sample is often the critical point of difficulty with these sorts of studies. But yeah, I mean, I think the idea of being able to detect, to get an idea, certainly of a change in population size based on, say, kin structure. I mean, if you have temporal data, you should be able to get some sort of sense based on, you know, what proportion of individuals are full siblings from generation to generation. If you see some great change there, say there's a much larger proportion of full siblings when you're sampling in the same areas, the same, you know, over time, same traps or something like that, that might indicate that there's been some decrease in population that's now there's been sort of one female is rebuilding the population in that area because everyone's full siblings. So yeah, I mean, something like that would make sense. And then I guess you'd see signatures of that over generations. So I mean, the stuff I was doing on roads, for instance, that was, you know, full siblings. The idea is the full siblings is the most clear sort of data, because it's really after you get beyond that, everything breaks down quite a bit. Full sibling is like, you know, one dispersal event or one generation in the past. Once you go to cousins or something, things you can still learn a lot from that, and you have a lot more data points, but it becomes more difficult to infer exactly what's going on. But presumably with population size, you'd be able to observe the population, say, rebounding after something's been hit, and then or presumably after a new invasion, you'd see all of a sudden, well, these used to be all related and now they're not. Yeah. So Mosh, did you have something to add there?
That's great. I was just saying, I've just linked one article to the people who are doing that work more specifically. I'm not sure whether it's the best one, but it is one. And it's just worth saying in that context, in the fishery context, they've mostly been working with just SIB ships. They haven't, it's more, in terms of the models they developed there, it's more straightforward. They can, you know, in terms of the question of population size, it's more straightforward to do that with just, you can actually accomplish that with just 1 or 2 levels, because you're not trying to come up with the idea of parent offspring size. It's just about, they've got some pretty sophisticated models, and I'm sure that, you know, they'd be the right way to go in terms of adapting it to other species. But there's already quite a lot of complexity with the fish they've already adapted it to. So maybe that looking at that would be a good place to start.
Because I was curious, because in Veronique's presentation, she said there wasn't any noticeable effect of the control zones, and I'm assuming that was just on overall trap catches. But I was wondering if you had used some kind of genetic method to look at the population size, could have you seen some kind of hidden actual effect of these control methods? I mean, it's just
you'd probably need a lot of data though, and I reckon you'd be able to detect that through, once you get the genetic data to actually detect kin, you'd probably be able to see effects on population size from drops in heterozygosity or something more easily. Though, yeah, I mean, it's I don't know. We'd have to look into what modeling you'd get from that, but yeah, that would be.
It's not that different to what happens in mark release recapture estimates of population size, because that's the whole point of the close kin mark recapture name. It's still the same basic model, which is in mark release recapture estimates of population size, you take one estimate of individuals, you mark them, and then you work out what proportion of your individuals that you collect a week, you know, whenever at the next time point are recaptured to the same group. This is the same thing. You just look for the related individuals versus the unrelated individuals in your site under whatever proxy for relatedness you're using, which is your mark. And then you basically just have to come up with a way of working out what you expect that relationship to be given the population size. And that's, I guess, what the models are doing. So it's very similar conceptually to what already happens with MRR. estimates.
Yeah, but a lot better because you don't have all those problems associated with marker release recaptures.
Yeah.
And we all know that when we work with insects and other invertebrates, we have huge problems because, of course, you know, as soon as you start marking them, they get excited and off they go. And you can get a whole lot of meaningless estimates, and that's the challenge, of course. So I think, you know, I mean, I was doing this in the future from now on. I'd always try and go straight to the molecular methods.
I've got a slightly different topic. One of the things that I've really enjoyed about this conference is hearing from all the endosymbiont people, you know, introducing the endosymbionts. It's just remarkable. But I was wondering about what the risks of taking endosymbionts from one species and putting them into another species, and whether we should be concerned about some of this. I mean, I'm obviously coming from a genetic manipulation problem background. I get all sorts of regulation I have to worry and be concerned about. But here, introducing a whole new species into other species, and I just wonder if there's something that we should pause and reflect on with some of this. Are there any concerns?
Charlie, that's a really provocative question, but unfortunately, we're going to have to cut it there because this session is rolling directly into a mini session straight after. So hold that thought, and I think we'll have to pass over to the next group. Yeah.
All right.
Yeah, why'd you have to ask that right at the very end? That was terrible timing.
Great question
for terrible timing.